I'd like to take a minute to talk about one of our sponsors, Parker Sporlan and Thermostatic Expansion Valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as 1, 2, 3. It serves thousands of unique applications. So 1, you just select the thermostatic element for your application. 2, you select the body style you need. 3, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
This uplifting cinematic experience.
I've got something important to tell you,
The
man.
big story is
Dig this and dig it deep.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, Kevin Compass, and we have two special guests from Falkonair, Christopher Micallef and Jeremy Franks. How are we doing, gentlemen?
Very good.
We're fine, thank
you. Brett.
Nice meeting you, Brett and Kevin.
Absolutely. Why don't we get started by just, telling a little bit about yourself, how you've got in the industry and basically a little bit what you're doing.
Okay, so I originally started being an electrical engineer, and back when I was still in study age, I got an opportunity to work with an HVAC company, and they sent me back to school to learn air conditioning refrigeration. So this was back in 1992. So since then, obviously electronics started coming out in the 90s. So for the old guys, with all the respect of all their experience, I became their manager because I knew electrical very well, and electronics. As we know, who's in the industry, electrical and electronics is, I would say, 90% of today's issues. Mechanical issues would be 10% on today modern age air conditioning, especially air conditioning. So my background goes back in, like I said, in the 90s, 92. In 2000, however, I was offered an opportunity to be one of the R&D consultant to develop three-pipe VRF. So VRF, for those people who knows VRF, have been created by Daikin back in 1995. Those were the early ones that I can remember. Two-pipe. So the difference between two-pipe and three-pipe, you can have multiple indoor units, but you can't have cooling and heating in the same time. You can either have them all on cooling or all on heating. However, three-pipe then in the 2000s was something needed, especially in colder climates, or even like in an office block where you have south-facing offices and north-facing offices, where the north-facing would want heating, and the south-facing, although it's winter, they would still need cooling. So this company that I was consulting with, clearly they needed to develop the three-pipe to be in the competition. So that's where then I've learned really in depth how DC inverter works, how the algorithm behaves, and what points you need to look at, how to control your compressor and your fan motors and everything else safely, but still produce the capacity needed. So that is basically my background, and this is where the smart compressor control came in, and this is where all the knowledge is coming from. So to be fair, this product is not a new product. So we're not inventing the wheel. The only thing that we're doing different is now we made it possible for fixed speed three-phase compressors.
Gotcha. And Jeremy, how about you?
Well, I come from the IT world, and but I've always had a IT world. And
Sorry, guys. Hold on.
A while now,
Hold on, Jeremy. I'm sorry.
That's okay. A while now,
Kevin. I'm sorry.
That's okay. Is my microphone given a cut off here?
No, I think what's happening is every single time someone's talking, we can hear it back through his speakers. Is it playing through your computer?
Yes.
No, Kevin. Sorry.
No.
What's happening to me? That's why I got confused.
No, it's not playing through my computer.
Huh. All right. Well, that's weird because now it's not doing it because it sounded like there was a delay.
No,
so every
it's
time
not playing through the computer.
Okay. All right. Continue. I'll edit out. Sorry, Jeremy.
That's okay. So, like I was saying, I just I like innovation. I've loved innovation products. I love taking them to market and working with distributors, working with other contractors. They're like-minded, businessmen, and just Chris and I connected 4 or 5 years ago through another innovation, and we just kind of moved on ever since here. So I've been working with him for many years now, and we've been bringing Falkonair's smart compressor control to market. And now we're on your show, and it's all done and over from here, right?
Yeah, right.
Pinnacle.
No, man, we were kind of curious, like, trying to sell something that's saving energy. Like, well, why shouldn't I just go with a VFD? I mean, what makes your product, so to speak, the cat's ass,
Yeah, so putting VFDs on compressors, especially reciprocating, it's not new. Mm-hmm. We know that Danfoss and ABB have been doing it for definitely these last 10 to 15 years. But they were doing it, and they could only do it on reciprocating. And the reason they could do it on reciprocating, because reciprocating, you can modulate the reciprocating compressor between 25 hertz and 60 hertz. Mm-hmm. So you need to have that difference of pressure, because they are controlling their compressors by pressure, mm-hmm. to have that modulation. However, scroll, nobody have done that before. And the reason we are different is because now we are controlling and monitoring by temperature sensors. So temperature sensors, we have the capability of not even going down to 25 hertz on reciprocating. We can stop at 35 hertz, which in my opinion, after our R&D and our testing that we did, when it comes capacity compared with consumption, because that is at the end of the day, that's where it's only going to affect not more than 3% savings.
Okay.
But the risk is much greater going below 35 hertz to 25 hertz than stopping at 35 hertz. So in our opinion, the last thing we want is to put a smart compressor control, save you energy, but a few months down the line, because we are going beyond 35 hertz to give you an extra 3% savings, there's a possible that the oil and it could damage even the armature, because now you're pushing the limits of that compressor.
Yeah, we've seen it where many a time where a new install gets put out there,
So-
and maybe the CFD isn't programmed properly, and then you end up having it go down to 15%, and then all of a sudden you have that compressor going off an oil failure.
Correct. And so this is where we have seen a very importance of what we are doing. We won't go down to below 35 hertz on reciprocating. On a scroll, we won't go below 45 hertz. But in the same time, the smart compressor control is actually monitoring what your compressor or how long your compressor was running on low speed. So the lowest speed scroll is 45 hertz and reciprocating 35 hertz. And then it will bring in an oil return sequence program. So again, an oil return sequence program is normal on every DC inverter system out there. So if you buy a brand new DC inverter system, you're going to find, if you put a monitor on, you're going to see at one point of time, it's going to do an oil return sequence. An oil return sequence is purely running the compressor at full speed to bring back any oil that went out of your compressor and it's flowing into the system. So our smart compressor control has got that also included. So it's part of the program.
So I have a question. When you say you're controlling with a sensor, so do you guys also have the ability to control to a saturated suction temperature with a pressure transducer, or is it only temperature at this time?
Temperature, we only control by temperature. So we look at the discharge temperature coming out of the compressor and the suction temperature going into the compressor. By looking at those two temperatures, you're looking at what health the compressor is working at. So if it is short of refrigerant, if there's some mechanical issues happening, we would know that on a discharge. So the discharge temperature would increase. Even partnering with a compressor remanufacturer, that's why he likes our product more than anything, because he actually even now is giving an extended warranty if they install our product, because we actually have a discharge temperature sensor on the compressor. But the way we are controlling, we're looking at both temperatures. By looking at the suction and discharge temperature, we are now getting the information that we need to understand if the evaporator needs more capacity or if it's satisfied, by just looking at those two temperature sensors. We don't need to look at pressure, because the problem with pressure, although it's what everybody is doing in the world on refrigeration, by the way, not on air conditioning. Air conditioning, none of air conditioning systems, even DC inverter, are controlled by pressure. And the simple reason is, as we knew before in the old days, that pressure correlates with temperature. It's not linear. It doesn't remain linear anymore when you start modulating your compressor. So if you have a fixed speed system and you have a clean condenser, clean evaporator, perfect load, you would get them linear. So your pressure and temperature would be aligned, and you would have to be fully charged with refrigerant. As soon as something like that changes, you start having a dirty condenser, you start having a dirty filter and evaporator, even simple, slightly short of refrigerant, your temperature and pressure do not align anymore. We've seen it thousands of times. So that's why we look at temperatures, because those are the indications to know the exact behavior, the condition of your compressor, but more than anything, what's the result coming back from your evaporator.
So, I mean, I'm trying to wrap my head around this because, I mean, pressure is temperature. I mean, it has in a saturated sense, it follows the PT chart. But, I mean, how does it, okay, so say you have a walk-in cooler, for example, and is trying to maintain 35 degrees. How are you guys maintaining that single system at 35 degrees? Is there also a box temperature sensor that the smart compressor controller is looking at, or is it just running off of?
We don't need it.
You're just controlling it.
Yes.
Okay.
And I'll tell you why. Because our algorithm, it will learn the temperature or the behavior of your evaporator if it changes. So we know that ambient temperature changes. Your temperature in your cooler changes because you brought in warm products. We also know that the thermostat can change. So you might commission the system when you are requiring 35 degrees Fahrenheit, and probably you decide, I want to go below 35 degrees Fahrenheit, I want to put it down to 30. So our algorithm, and that's why we call it a smart compressor control, because it's learning the behavior that your system requires. It's working 24 hours. So even if your compressor is switched off, we are actually continuously running the algorithm 24/7 nonstop to learn your ambient temperature and your behavior on those 2 points. By looking at those 2 points, you'll be amazed how much information you would learn, what your evaporator condition is at, what your evaporator requirement is, and that's where we speed up and reduce the compressor capacity. So at the moment, all you have at the moment, Kevin, all you have is a fixed speed compressor. Let's talk BTUs. Let's say, for example, just to be straight, let's say you have a 20,000 BTUs compressor. Obviously, to have a 20,000 BTUs system, you need a 20,000 BTUs evaporator and a 20,000 BTUs condenser, correct? So all of those, that will give you 20,000 BTUs of cooling. Now, however, we know, because we've been in the industry, like all of us on this call, that once your ambient temperature changes, whether it goes up or down, so if it goes down, automatically your 20,000 BTUs are going to be increased. We know that, so we are taking advantage of that, because we know that when your engineer designs your system, he's never going to design your 20,000 BTUs for the coldest day of the year. He's always going to design your system for the 2-day or 1 week, wherever you are in the country, the hottest day of that area. So, yeah.
Real quick question, actually a two-parter. So first off, does the smart controller get installed when it's on a rack system? Because it sounds like the smart controller is more real apt for a split system, or I mean, like a single evaporator, single condensing unit.
We have installations on racks, and we have installations on DX, which is single split, and we also have installations on just a one compressor and 2 evaporator refrigeration system. It's always going to work.
So there's no signal. There's no signal from anywhere from the outside control that's actually touching your compressor.
No. So we're just looking at the suction and discharge, and whatever that temperature is, we would adjust and do or actually create or give the capacity that the compressor needs. Now, when it's a rack, you need to do obviously on one on every compressor. So you can't just do one and then hope for the best for the others. The other thing that you need to understand is our system does not switch off or switch on compressors. We would still rely on your existing controls. That's why a lot of OEM manufacturers like our product, because we're not intruding into the Einstein controller or whatever control the system has got. If you have a safety that you want to switch off your compressor, it will switch off because we're taking a signal of your existing compressor contactor. So once that contactor switches off because it's a safety issue, or even simple, we want to switch it off because we don't need the compressor on, we will switch it off. Okay. The only difference that we're doing is putting our foot off the gas. At the moment, you have a fixed speed compressor running full whack. Even if your condenser becomes efficient because your ambient temperature now is cooler, you're going to have an expansion valve. Basically, you're going to have the mass flow from the compressor being produced by your condenser, being pushed through the expansion valve and fighting with the expansion valve, telling it, I don't need so much liquid. So it's going to start shut down. Because obviously, if it lets it all in, then you're going to flood your evaporator. So what we are doing different, we're going to sense that that is happening, and then we slow down your compressor. So now your expansion valve is going to fully open. And that's how we're saving energy, and that's how we're doing it. Because we're going to know the result coming out of your evaporator.
So how do you guys, so stay on like a rack system, how would you guys anticipate the loss of temperature, obviously, from the evaporator to the rack? So I mean, some of them, I mean, you have poor insulation. I mean, you have stores that like the superheats aren't all the best. I mean, say you may have 20 or 30 degrees of superheat at the rack. I mean, is that controller going to realize that and adapt to that? Because I mean, how would you control the suction temperature when it's going to be higher like that?
That's exactly what that it adapts to the condition that it is in. Because even if the installation was done perfect, which we know that when it comes to a quick installation, we know everybody wants to do a quick installation, and probably he doesn't do a perfect insulated installation. It will adapt to that condition. So what it's seeing, it will remain giving you the same capacity. What it doesn't do, however, it's if you have a poor installation, it's going to keep on giving you the capacity that you had before. So one of the things that we would require for the contractor doing a survey is look at the installation. If it's got a poor insulation or if it's far away, take note. Not because it's going to make any difference, by the way, but the algorithm in this smart compressor control is going to notice that, and it's going to probably run a little bit more safer. So when it comes to savings, you probably won't get your total maximum that we're seeing on some jobs, like 60% or 50%. That's going to affect your savings. So you might get your minimum, which is 25 to 30%. So when you are doing a survey, they would tell us, the installation is not that okay, so don't expect any more than. We are like being conservative. We're not, we don't want to give crazy numbers that you never be achieved. But if you have a poor installation, you probably won't get your maximum savings that we're seeing on other good installations. Because the algorithm is going to go of what you are presenting it with.
So I'm still confused. I'm still thoroughly confused. I'm trying to wrap my head around this. Because I don't understand how by the discharge and the suction temperature, because that's what you guys are monitoring, correct?
Correct.
How you're controlling the capacity of that rack to maintain a certain suction pressure in order to maintain a certain saturated for the rack to actually function properly if your smart controllers are basically taking the place of the energy management system is really what it sounds like. It sounds like they're their own compressor control.
But again, we don't switch off the compressor. So what you have to remember is, if that's why that's why our algorithm is unique. Our algorithm is monitoring how long it's going to run for slow speed. So we're not. Some people think that our system is just, we put it on, within seconds it's going to run on low speed, and we're going to say, hey, look, we're saving you energy just by slowing down your compressor. Our system, if you have, let's say you have a restaurant and you completely open your doors now, to the outside world. Our system is not going to slow down your compressor, and our system is not going to save you energy, because it behaves exactly like a DC inverter system. If you buy an efficient, latest design DC inverter system and you install it undersized, so in other words, it's like having a door open, that DC system, believe it or not, although it's classed as a 1920 Sears, it's actually going to consume more than a fixed speed compressor system. Because the reason for that is because if it's not catching up, if it's not being satisfied, if your compressor is not getting the right suction temperature back to its compressor, it's just going to run at full speed. And exactly our algorithm, that's how it works. So we're only going to slow down your compressor and save you energy once we have a satisfaction of suction and discharge temperatures.
Okay. All right. I think I got this now. So the compressor, the EMS control is basically still going to cycle off the compressors based off of suction pressure, but your system is
Correct.
basically cycling and going up and down
Correct.
with the frequency based off of what the discharge and the suction temperature is doing.
Correct.
So that being said, now that it finally rang true, you guys are actually, if you would have an issue, for instance, like let's just say if you have a hot gas solenoid leaking by into the suction, which then in turn is going to take discharge gas and throw it into the suction. Okay, can we agree on that? In turn,
correct.
because you guys are now going to have an increased suction temperature based off of your smart controller, these compressors are probably going to ramp down.
There's two things. There's two things it would do.
Okay.
So first, it would ramp up because it's now thinking that the evaporator,
it's not getting enough cooling.
It's not
trying to bring down that mass flow,
exactly.
Right? Okay,
but the other important thing to protect your compressor is, after a certain period of time, it will shut down your compressor and call an alarm.
Okay, so based off
Again,
of that,
to protect your compressor, because if you have hot gas flowing into your suction, your discharge temperature is going to shoot up.
Okay, so if you were to have an instance where either hot gas is injecting into that way, it would try to. It first thinks that it's not bringing enough cool gas back to the suction, so it thinks the mass flow's not up, so it increases its speed. So let's just say 5 minutes goes by, and it's like, nope, something seriously screwed up, and then it shuts down. Got it?
Yeah, correct.
Kevin, it took me a bit. Do you have it?
I mean, it makes more sense. I mean, it makes more sense that the original controller is still controlling it. I mean, I'm still trying to kind of wrap my head around a single application, how it would actually know it's making box temperature besides the superheat's good. I mean, that's where I'm kind of wrapping my head around. I mean, you'd still need the conventional controls to say a conventional unit. It's still going to have a pump down solenoid, and is that correct?
No, you still need everything the same. No, we don't. That's the beauty of our product, Kevin, and that's why everybody likes our product, because we're not messing with your existing controls.
Sorry.
We're not doing anything like that. I mean, because we know that in the field, there's a lot of controls that shut down your compressor earlier, keep it shut down for long periods of time, and telling you, hey, we're saving you energy. Our control, like I said, if you leave the door open of your fridge or chiller, it's not going to slow down your compressor.
You're not going to save shit for money. So we're not actually controlling suction pressure.
Exactly.
You're essentially saving energy based off of the almost the compression ratio. If you really think about it.
We're just taking the extra liquid production, the extra mass flow that you don't need. It's all about mass flow, right? And we know, like I said, I can make your 20,000 BTUs, going back to that argument, 25,000 BTUs, just by increasing the delta T on your condenser. Because believe me, we've done a lot of experiments when doing DC inverter. Because DC inverter, believe it or not, if you buy a 5-ton system, it can actually give you 6 to 7 ton.
So, hold on. Another question. Now that I actually understand this now. So you overrun the frequency past 60 hertz based off of the suction and the discharge?
No, we do not.
Okay.
No. The maximum we run is 60 hertz.
Okay.
And the minimum on reciprocating is 35 hertz, and on scroll is 45 hertz.
Gotcha.
So we know that on scroll, because this is another important issue, we know that scroll, if you run between 45 hertz and 53 hertz, you are getting your highest COP on that scroll compressor.
Gotcha.
And if we manage to give you the highest COP, but still obviously giving you the extra capacity when you need it, then that's how we're saving you energy.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries Serviceable Oil Floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Well, I felt dumb for like at least 15 or 20 minutes of that 27-minute conversation. Jeremy's laughing, but he's on mute. I literally, like, he's talking.
You don't understand how many Zoom calls we've been on in the last several years, and it just takes a minute sometimes, my friend.
You're gonna see this more, because obviously we are hitting the refrigeration world.
So
you're gonna see this more. I tell you where you're gonna see this. We've already seeing it actually. I've seen an Emerson controller. Although they have all the pressure controls and everything, they still have a separate discharge temperature on their discharge. And when I've asked the question, why is that there? They said simply to get the warranty from the compressor manufacturer. So we have a partner who's a compressor manufacturer.
Yeah.
And because we are installing the sensors where we are installing them, he's actually extending the warranty.
Because it actually has an internal protection. So now that we have that out of the way, what the temperature sensors, are they replaceable?
The way I've designed this, I didn't want to design something that to get that sensor you need to go to Japan. You just go to your local wholesaler, and it's a simple NTC sensor.
10K2? That'd be easiest.
10K2.
Oh, there we go. I tell my guys.
Two of them come in the package.
Okay.
Yeah. To be honest, I have a lot of experience, not just developing VRF, but even seeing a lot of technicians scratching their heads and struggling after sales service on DC inverters. And I know how painful it can be, not just for the technician out in the field, but even for the company owner, that you tell them, oh, I need to order 3 boards. They're going to cost you 2 grand, and you need to wait 6 weeks for them. Because the ones that we have in stock, it's about yeah, but I'm just being conservative. I'm being conservative. But the worst thing about that is some manufacturers on DC inverter systems actually change their design every 6 months, so it even makes it worse. So the way I've designed our product, it's even got self-diagnosis. So if you lose a sensor, obviously it's going to cut out on faults and tell you which sensor is faulty. So you don't even need to get your multimeter to check which one is faulty. It would tell you sensor 1 is out or sensor 2 is out.
Gotcha. And so what typically what is it trying to control with the algorithm? Like, as far as is there a different for every single compressor? You're following the COP chart for every single compressor?
So that's a good question. So we have a 4 dip switch setting. 2 of them. So one of them is obviously degrees Celsius and Fahrenheit, whatever you prefer to use. Normally it's Fahrenheit in the US.
Mm-hmm.
We have another dip switch that actually you can install the smart compressor control on a fan motor now. So if you want to use it on a large air handling unit on the evaporator fan motor,
Mm-hmm.
you can use the same control on an evaporator fan motor. So you tell it if it's a compressor or a fan motor. And then we have the last 2 dip switches to tell it if it's a reciprocating or a scroll.
Okay.
So once you tell the smart compressor control what you are installing on, then the algorithm takes over.
So do you have
But
to
it doesn't need to know the refrigerant.
do you have to do the oil return if you're have an oil separation system?
Okay, so that's another good question. So when you have
Sorry.
an oil sensor,
Mm.
so when you have an oil sensor, we know as soon as your contactor comes on, it will expect the oil pressure to change.
Yes.
Correct?
Yes.
So some systems we basically disable the 3 minutes delay that we have. So we on an air conditioning system, we have a 3-minute delay. So once your compressor switches off, it won't be able to come on before 3 minutes.
Mhm.
But because refrigeration compressors do have the compressor, the oil pressure sensor, it will throw a fault if it doesn't sense the pressure change. So we have to disable the 3 minutes on that
Gotcha.
particular. But we know that if you have that, you're already covered and protected with the 3 minutes delay on your control, whether you're using Emerson or RDM, whatever control you're using, because there's always going to be that protection for that compressor.
So if they're going to implement, go ahead, Kevin. Sorry.
I have a question. So this whole setup. So I have something I'm very interested in with this. So we have a lot of dehumidification issues. So on older stores where they have no reheat, where the reheat's been cut out, running rack stores, and then so they're going through and they're putting glass doors and everything. So they're doing these glass door conversions, and the store AC has not got much loving, to be honest to you. Like it's been neglected. It's not needed to run most of the time. And I mean, the cooling was done through the cases. Well, now they go and close up the cases, and now we have all these dehumidification issues. So I'm kind of, trying to help come up with ways of dehumidification. So, I mean, we're doing gas reheat, like just trying to use, modify the unit to make it work. I mean, yeah, that works, but it's not efficient. So, I mean, there's other ways we have to do some kind of reheat with the gas. I mean, it is what it is. I mean, but so I'm looking at ways of, obviously slowing our fan down and lowering our saturation temperature right around like 30, 35 degrees, 34 to like 35 degrees, getting that saturation temperature down. We do this in a lot of newer rooftops. They get that saturation temperature down by oversizing the compressor and using a digital or a drive, and they're allowing it to remove much more moisture that way. Now, is that a capability that you guys can do? Can we, essentially use our EMS system to lower the fan speed with the drive, and you guys, control that saturated temperature with that suction temperature sensor to, effectively remove more moisture with the dehumidification that way? Is that a possibility?
Okay, so what you just said, the reason for what's happening now is because you had a certain size of cabinet, and now because you put in doors, the size became smaller. So now you have an oversized compressor. So the reason that we can basically help you fix that problem is because now we can slow down your compressor. Because once your cases are closed, your evaporator temperature is going to be satisfied very quickly, and then we're going to slow down your compressor. So now your compressor is going to be ticking over, and it's going to increase or help not to have an oversized system cooling your undersized evaporator. Because you are slowing, once you slow down the compressor, you are reducing the capacity. So once you reduce the capacity, you are automatically dehumidifying, because the longer you run your compressor, the more dehumidifying system you are having, right? You would have humidifying when you are short cycling, and most probably that's the problems
Correct.
that you're having at the moment.
More so, it wasn't more so on the refrigeration side, because we're already adding a VFD compressor, running longer, and getting that saturated temperature down is going to dehumidify the space more. But would that compressor be able to control that, or would the smart compressor be able to control in that situation in order to react to that slowed down fan speed in order to remove more moisture?
Yes, it would. Yes, it would. Because if you slow down your speed of your fan motor, your suction temperature is going to be reduced. It's going to go down. Correct? It's going to be cooler. Because you are
correct.
Exactly. So now our reaction is going to be, okay, I'm satisfied. So I'll even slow down your compressor. So they're going to run, although they are independently installed, they're going to basically run in sync. If you increase the speed of the fan motor, we're going to know that you have a higher return suction. We're going to increase the speed of the compressor.
The only problem I see
this seems like... Go ahead, Brett.
The only problem I see with that is your temperatures. It's just trying to maintain, the COP based off the discharge and the suction temperature, right? So if it starts, the only thing I'd be afraid of is that you'd maybe have to widen the band, Kevin, on the air conditioning to give the smart compressor more time. Because I don't know how fast the algorithm is, right? So if
it is very fast. It is very fast. It's not minutes, it's seconds.
Okay.
So it would react to the
fan. It's very accurate.
So say if we humidification, lowered the fan speed, it could start slowing down that. I mean, this seems like a really good application for doing this, for like implementing, I don't want to call it hillbilly dehumidification, but it's better than what they have at the moment. Getting the fan speed down and reducing the capacity of the compressor would at least allow you to run that at a better saturated temperature to remove more moisture. I mean, you would still have to do some form of reheat, but that seems like a pretty good deal right there.
Most of our clients look at energy efficiency, and then they kind of think of the compressor safety as a secondary. You're definitely tapping into the third, which is the least commonly talked about, humidity control.
Capacity control, essentially.
Right.
That's what we're trying to do.
That's exactly what that is. Yes, correct.
And that's.
I mean,
that's
your guys' product seems like it would be an awesome application for capacity control in like rooftop units in like spaces or like small stores where they don't have the capacity control for the rooftop units and stuff like that. I mean, to be able to dehumidify, I mean, it seems like an awesome application for.
Yeah.
I would say the best application would be large rack systems. That's what I'm seeing.
Yeah.
Well, there's different applications. So we did roof package units. We did everything really. Roof package units. We did DX. We even did air-cooled water chillers. Again, that was that scenario where you had 4 compressors. We did 2 out of the 4, so we didn't need to do all 4. But the capacity, so you see the temperature glide and sort of up and down, because you got compressors coming on and off. You just see it like that, and that's going to fix everything, believe it or not.
But on a rack system, you said that every single compressor would have to be equipped with this system, correct?
Yes, on a rack you need to do every single compressor. You can't. It depends. So let me rephrase that. So if we know that a rack system out of 7 compressors, we know that you have 2 compressors not doing anything, then it would be waste of money or investment to do the other 2, because those are classed as redundant compressors. Just in case one fails, it's a redundancy.
All right.
But if they're all in line and all working, yes, you need to do them all.
So, all right. Well, then this question then, what have you seen pre and post as far as KW, but also as far as pre and post graph on a suction control? I want to know, like, how, is it overshooting now that we have this secondary controller that's basically just trying to control off the COP of the compressor?
Keep in mind that we don't have the capability of putting on compressors or switching them off unless there's a fault. So we still rely on your emission control or whatever control you have to put on compressors. The only thing different that we do is if we see that we're getting a satisfied suction and discharge, we would slow it down, depending the ambient, depending the algorithm, depending what it was before.
So you could have it essentially overshooting if you have poor insulation.
If you have a poor installation, so let me give you
not installation, insulation. Like on
insulation is bad installation, right?
Oh, sorry.
You know what I mean? So if you have bad insulation, which is, for me, I see it as a bad installation. So the worst cases where we had not a good insulation installation, it was the minimum, the maximum that we could have seen, not more than 25% savings.
Yeah, no. The only reason why I say specifically bad insulation, because, let's just say someone has the idea where they're like, I'm going to put this on all my compressors. I'm going to save a shit ton of money. And then they don't because they didn't change out the insulation.
A pre-survey needs to be done.
Okay.
And when you go into energy efficiency, we need to be honest with ourselves. You can't make a system which has got a dirty condenser or fins that's just been corroded of a condenser, and you're going to make it more efficient. Because basically, you're kidding yourself, right?
That's not what my wife says. She says when I put on a suit, I look awesome. It's the same freaking thing. It's like putting a suit on a turd. It makes it better, right?
When it comes to energy efficiency, it does not. Energy efficiency. It's like what I said earlier. If you have bad seal with your chiller door, so basically you got a leakage of air, and it's like having the door slightly open. It's very difficult to save energy. I have seen systems which are leaking, and they have this idea of, by putting 1 tank of refrigerant every month, we're going to save them energy. And I walked away. I said, no, before you fix your leak, I can't save you energy. First, you need to fix your leak, because the idea of this company was fixing the leak, it's going to have to shut down the store for a day to find the leak. And that's going to cost them more money than putting one tank of refrigerant a month. But we can't save energy if your system is not working properly. Yes, if you have a little bit of bad insulation, if you fix the insulation, which shouldn't be a big job, then you're going to save more energy. But if your system is really bad, then it's beyond saving energy, right?
I'd like to thank you. You just ruined 16 years of marriage because now I know that I've been lied to. Unbelievable. Kevin, you have any more questions? I'm fragged out.
What's your guys' average return rate? Like ROI, like what does an ROI look like on an average, say like a package unit and like a rooftop unit and or like a rack system?
Okay, so that depends. First of all, what's your energy rate where you are? So what is it? 15 cents, 10 cents of a kilowatt?
And going up?
I think 9. I live in Texas. I don't know. Energy's cheaper.
Yep. Let's say it's 11 cents. So if it's 11 cents on not smaller than a 10-ton system, we have seen, if you don't want to be aggressive on your margins. So when we say aggressive, you work with a comfortable 30% margin, including the VFD, including installation of the labor and our product, you'll be looking of an ROI of less than 3 years.
Wow.
2.5 years. If you are working in a high energy like California, your ROI would be less than 2.5 years, closer to 2 years. But again, depending where you are, in the country, right?
So Brett, when I'm working with contractors here in California, it's not uncommon to see 300% profit margins.
Because their energy rates are high.
The energy rates are 18, 19 and climbing.
Yeah, exactly.
But when we say this too, what Chris, neither one of us mentioned, is we're not calculating in any tax incentives or rebates from the utility companies.
Correct.
So in each area has so many different ways they run that. But when you really get down to it, we have contractors. I think the job could actually get pretty close to net zero with incentives in places like Seattle and New York.
So some utilities are actually one just agreed last week. They're actually financing the jobs for you.
Oh, it's right here in my market, PG&E.
Yeah.
PG&E just authorized onboard financing.
They just classed the smart compressor control as a tier 1.
Wow.
So basically, you pay it within 5 years, 0 interest with the utilities direct.
How are you guys dealing with the supply? I'm sorry. Go ahead, Kevin. I didn't.
Go ahead.
How are you guys dealing with the supply demand on parts and stuff?
Well, the VFDs, we see contractors struggling, but the advantage that you have with the smart compressor control, it's compatible with 7 different brands. So we do have stock. So we thought about it much before. The beauty of what we do is because we manufacture our own. So we're not dependent on people, other countries or other areas to do their own thing for us, and we're just waiting for them. But VFDs, we've seen brands that they have a 16-week wait. Some brands only have 2 weeks wait. So depending what brand you're working at that time, you have an option to change brand. So our smart compressor control is compatible with ABB, Schneider Electric, Allen Bradley, Rockwell, Tico Westinghouse, Fuji, Yaskawa, and Invertech. So any one of those, our product is compatible with. So if one is, say that again.
Nidec and Danfoss?
No, those two, no, not yet.
Okay. How are you guys meshing them? How are they communicating together?
Modbus.
Oh, okay.
Because with Modbus, we are getting the information off the drive. So we're not, so we had some contractors telling us, oh, why don't you do 4 to 20 milliamp? Because that is a stupid way to control a VFD, because you're just sending a signal, but you're not seeing what the VFD is actually doing. And because we are just giving not just a savings, but we need to protect your compressor, we need to know what the VFD is actually doing, not just sending a signal. But by Modbus, we know what that VFD is doing. But even better, we are now gathering that data, including your amperage and your voltage, and now we can have the access to send it on cloud.
Yeah.
So now you can see your settings, you can see your VFD, you can see your consumption, you can see it live or recorded on cloud.
Yeah, tell them a little bit more about that, Chris.
So we are still in testing mode at the moment, because we do a lot of testing before we outlay something.
Mm-hmm.
But we have a plug-in board that plugs in the SCC one that we're talking about, that
Mm-hmm.
you can connect it to the internet, and then you can see the 2 temperature sensors. You can see what the frequency is on your drive. You can see the voltage, the amps, and the kilowatt consumption live on cloud. So you can either have it recorded, so you can go back history data, or you can see it there and then. And you can only do that by Modbus.
Is there any way to?
Yeah.
Is there any way to use the mod points on that to integrate it to the EMS controller on site? I mean, it seems like that would be something a custom, like especially in a supermarket application. These customers are all data driven. It seems like that would be like a huge thing for them to be able to, say, integrate with Emerson or Danfoss or Novar to pull those data points out of there, or RDM, and bring them back to the actual home controller and for logging and easy access.
Yeah, so all drives have that access. That's why we use Modbus. So all drives, I'm not sure about Tico Westinghouse, but I'm sure ABB and Schneider and Yaskawa have that access, that you can actually read what we are saying, that what we are transmitting on cloud. So instead of transmitting on cloud, you can take it for yourself and put it on your RDM controller or even your BMS system.
What about the actual smart controller? Can we communicate with that off Modbus and grab data from it, points from it?
Not the smart compressor control. For you to get data out of it, you need to have the plug-in board that we're working on at the moment, and then you can take it off there. So instead of sending it to cloud, you can put it on your BMS system. But you cannot control, you can only monitor. So basically, you're only going to see what the smart compressor is doing. You cannot control it, because the algorithm controls.
Would they still be able to see the data from the VFD as well?
They would be able to do that, because we are getting that data, and then we're outlaying it from a different card, which on that card then it's outlaying on to our cloud. Now, instead of sending it to our cloud, you can translate it back into your RDM control. The only difference is it will be probably a different language, because they communicate with different register languages. We would need to know what language that is, or what they're using, and then we would need to implement that for the RDM or for any controller that they need.
They'd have to get a description file written to basically make sure they can see the same language like anything else when they integrate
exactly.
it.
Yeah.
Okay.
Yes.
Wow, I learned a lot today. Oh, and I wasn't laughing at you. I was laughing at the fact that usually Kevin's the first one out of any of us to start bashing, pieces of machinery. So when you did it, I was like, oh my God, that's hysterical.
I don't like bashing anybody, to be honest. But sometimes you get a lot of these, with all due respect, office guys, and they've got one mentality, and they think that just because Danfoss did it, or Husband did it, or whatever big brand did it, why aren't you doing it? Because we're not stupid. We do it this way because we need to understand that we need to protect.
See, I
Because-
like this guy more and more.
Well, listen, when you have been in the field like us, all of us here, you would start to realize, these big brands and what's the good and what's the ugly and what's the good thing, So, and the reason this product is being, to be honest, I am very surprised. Nobody is slagging it off. Actually, people are coming on, like Johnson Controls just came on 3-4 weeks ago and said, I never seen this product before and I love it. It's because they were always driven by what their big company told them to do. They were never allowed to see what they've learned out in the field and let's do a simple controller. There's nothing better than doing simple. Because it's easier for troubleshooting and it makes everybody's life easier.
So, do you guys have any major chains in the U.S. that are running on this right now, or do you have any? How many rack systems do you guys have out there right now?
So we can't mention the chains that we are working with, but
NDA, Kevin, NDA.
No, it's not the NDA. Even with the having NDA, we still can't say, not yet. They don't want us to say it yet. They don't want us to say who they are yet. The reason is more, I think, competition more than anything, because they want to be first, to market, not to have their because if you think about it, our product, some supermarkets, large super centers I'm talking about, we have done a big dent in their energy bill of up to 20% a month. Now, if you think about it, that is 20% profit that they never had before. So that's basically going to put them in a better seat than their competition, because if you're saving, the last bill I've seen was like $5,000 a month. That's extra money which they never had before. So they don't want us to say who they are yet, but we are talking to another big chain. Again, they don't want us to say who we're talking to, but they're coming in. They're coming in now. This product has been out there for over 3 years. We have the oldest one is 3 years old in Indonesia, believe it or not, because we sold this product outside the US 3 years ago. And then we only came to the US in 2020. And then obviously COVID hit us. So we had a slow start. But now everybody's coming to us. We even have, I don't want to mention the VFD manufacturer that want us to make it compatible with them. Now, I know why, because obviously they're seeing that, people are buying Invertech, which nobody have heard of before, and they're buying Yaskawa. And so what you have to remember is this: Yaskawa, Fuji, Invertech, all of those brands never did compressors before. They always did just fan motors or pumps. But with our product, now they're coming into the HVAC world. They're actually seeing us as a threat, because those guys are now going to take some of their market, which those guys who were in the HVAC world were Danfoss and ABB, and a little bit of Schneider.
That still means that you still need a VFD. Like, your controller can't work independent
No.
without a VFD.
No,
okay.
you always need a VFD.
So so your smart controller, just give me a quick dimension. Bigger than a bread box, 2x4. What is it?
Box.
Huh?
Cigar box.
Cigar box. Okay. So a cigar box gets mounted, talks to the drive via Modbus, drives off of basically the COP chart, depending on the temperature of the discharge and the suction.
Yeah, correct.
And shitty insulation is bad.
Well, it's always going to be that,
So if you do a quick comparison on the energy efficiency savings, you take a VFD with one of our controllers. Let's just say it's going to go on a 10-ton RTU. you're going to save somewhere around that 20,000, 25,000 kWh annually. Well, to offset that, you're going to have to put on 30, 40, 45 solar panels to create 25,000 kWh annually. So we know that's at a cost of what, 45, 50,000 versus a fraction of the cost over here. And you also know that facility probably had more than one compressor on the roof. So apples to apples, energy efficiency, this kills it.
Yeah, and the other thing that that we need to realize is, if we're going to talk green, and let's face it, I'm not a green guy, but let's talk green. How much CO2 you emitted to create those solar PVs, and how much CO2 you emitted to create the smart compressor control. So the smart compressor control is just a PC board with 2 sensors. The solar PV, you need a lot of heat and a lot of coal to create a solar PV.
Okay.
So it's much greener than any other renewable product out there, just for the sake of even producing it, manufacturing it.
Gotcha.
I have no problem going down the rabbit hole with that. With anybody who'd like to know more.
Yeah, I'm happy to do a Zoom call with whoever wishes to know more detail.
So, Kev, you got anything else, man? I'm tapped out.
No, I mean that was a really good one. I mean, it took a little bit in the beginning to get past the whole suction temperature thing, but I mean it's it makes more sense now. I mean, I would love to see some like data. You guys, could send that over to us. I mean, some graphs, maybe some suction graphs off the EMS after it's been implemented, and some actual like real life KW or some KW graphs, if you guys have them.
Actually, what we can do, Jeremy can send you an explanation by one of our customers. Is a contractor up in Boston that he is selling his own controls. I don't know if you've heard before about them. NRM. They have their own controls that they control the evaporator fan, they control defrost. Anyway, so they've been doing this for over 25 years. So because of that, he obviously been monitoring everything for these last 25 years. So he installed one of our systems on one of his sites, which has been installed since 2017. And he actually explains, this is what I've had before. And since I've installed the smart compressor control, this is the behavior. So it's actually explained on a video. So Jeremy can send you that video. And you can see...
Was this guy at AHR this year?
Yes, he was. Yes.
Older gentleman.
Correct. Emery.
I met him. Someone introduced me to him when I was over at the Sporting.
He's a nice guy.
Man, smart as hell, dude. He makes his own electronics and makes his own panels because he was showing me pictures. Yeah.
Correct.
Oh shit. Small world.
Yeah. So he's done more of a full video white paper that he's showing you live what the readings are. Can you say?
Yeah.
Let's see it.
He's a big fan of our product because with his controls, he used to save a circa of 30%. Mm-hmm. Now with his controls on our product, he's going above 60, 70%.
Wow.
So yeah.
Wow.
Okay.
Well, guys, I appreciate you guys coming on. That was amazing. Yep. That was awesome.
I really appreciate it. I mean, maybe we'll have you guys on again, and I would love to get some of that data and maybe forward it off to a customer. And I want to try to push you into this a little bit.
No problem.
Look forward to working with you, Kevin and Brett. Appreciate your time.
Thank you, Brett. Thank you for the opportunity. Thank you. Nice meeting you, Kevin. Bye-bye.
Hey, good effort. Way to go. Damn. You assholes know I'm being sarcastic, right?